for joining tonight's TI Technology webinar hosted by Texas Instruments, where tonight we're going to take a look at kicking off your school year with using TI technology in your calculus classroom. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. Tonight we're really lucky to be joined by our two panelists, Vicki Carter and Corey Bobby. Vicki has been teaching high school math for a mere 42 years and currently serves as the math department chairperson at West Florence High School. She's a former co-chair of the AP Calculus Development Committee and serves as an exam leader at the AP Calculus reading this past summer. She received the T-Cube Leadership Award in 2015, and Vicki has served on TI-Nspire authoring teams and has presented at many national, state, and local conferences. Vicki, thanks so much for joining us tonight.
Oh, it's a pleasure to be here. Hope we can let everybody know some great things about calculus tonight.
And Corey is in his 22nd year in education and currently teaches Algebra 2, ACT Math, and AP Calculus at Benton High School. Since joining the T-Cubed community in 2001, he has worked on curriculum development and workshop instruction, as well as creating online courses and videos for TI-Nspire technology. He serves as an AP Calculus reader, and he received the T-Cube Leadership Award in 2011 and the 2017 PAEMST finalist for the state of Arkansas. Corey, so great to have you with us tonight. We're expecting a large crowd, so your audio is muted. Feel free at any time to send any questions to Corey or Vicki using the Q&A window on the right side of your screen. As a reminder, the session is being recorded. We'll provide a link to the event certificate of attendance at the conclusion of the webinar, along with a link for all the documents that are going to be used by myself and Corey and Vicki. So the best thing for you to do tonight is kind of just sit back, relax, ask questions if you have them, follow along, but not necessarily with your technology. Just sort of sit back and relax. The best way to follow along with your technology is with the recording, which will be out in a couple of days. You'll automatically get a follow-up email with that link for the recording. And with that recording, you can really follow along at your own pace with your technology. We hope you don't have any audio issues, but in the event that you do, try selecting Communicate at the very top of the WebEx menu and choose Audio Broadcast. At this point, Corey is going to discuss our agenda.
Okay. Well, we've already kind of done some of the welcome introductions. You'll get to know Vicki and me a little bit. We both kind of just let it, just tell you what we think. But we're going to start by going over the 4 approved AP Calculus calculator functions, and then we're going to look at how we can use them and how students need to know when and how to use their calculators. Then we'll move into some work with limits and possibly the difference quotient, looking at graphs and tables and trying to find numeric and graphical representations of limits. And finally, then we'll move on and we're going to explore the famous escalator problem. If you're on Twitter, this is the problem all the kids made fun of this year. So we're going to look at how you can use the calculator to explore this problem. And we're going to try to build some extensions on it so that we can use the calculator and technology to enhance problems we already know.
Thanks so much, Corey. And Vicki is going to discuss our expected outcomes for tonight.
Okay, well, given the things that we are planning to go over in our agenda, we hope that by the end of the webinar you'll have a little better understanding of how to use the graphing app on the TI-Nspire. We're also going to do graphing on the TI-84, kind of complement what we're graphing with both calculators and discussing some things that students really need to know how to do as they approach AP Calculus or go through the course of AP Calculus. One of the things we'll be storing intersection values. We'll look at that. We are going to take a few minutes to look at piecewise functions because they lend themselves very nicely to working with limits, and we will look at how to do piecewise graphing on both the TI-Nspire and the TI-84, and then go into limits from that. We'll use a little bit with tables and graphs, possibly with looking at limits, and do as much as we can. And as Corey said, we'll pop into that old escalator problem and maybe do a little bit with it as much as we can. So hope you enjoy tonight.
Thanks so much, Vicki. Corey, it's all yours. Feel free to share your screen.
Okay, well, we'll be sharing my screen, and you should see the cast here. Let me minimize this out of the way. Oops, no, I wanted to go the other way with that, didn't I? How do I escape out of that? Oh, there we go. Hit the wrong one. That's the one I wanted. Okay, so we're using the, we're starting with the cast this evening. Sorry, I've been at school all day, and I'm still here doing it, so it's getting used to it. We're going to begin by looking at the 4 calculator-permitted operations on the AP exam. And Vicki, do you want to state those since you're the AP exam leader? Or
Yeah, I'll be glad to. So these haven't changed for quite a number of years. The first thing is that we expect students to be able to sketch a graph of a function that we would give them in some arbitrary window. It might be a kind of a standard window that they would have when they first put the graph on their calculator. They may have to manipulate their window a little bit in order to see the special features that they may be interested in with that particular function. We want them to be able to solve an equation using their calculator, either graphically or on the calculator application. And that also would include finding zeros, because obviously that would be an equation that we've set the function equal to 0. Those are very important when we're working with area and volume questions, but it's also just good in some of the other kinds of problems that we would work with, that they can solve equations with their calculator. Then the 2 big calculus concepts are a calculator derivative at a point, and so they're actually approximating the slope of a tangent line at a particular x value, and they've got to be able to calculate or approximate a definite integral. So those are the 4 things that we expect all the students to come into the AP exam knowing how to do on the calculator.
And Vicki and I both teach with Nspire CAS models in our calculus classes. I, however, use 84s in my Algebra 2 class, so I have both models actually in my classroom at all times. And so I'm going to take the role of the 84, and Vicki's going to be the Nspire. But we are going to use CAS, although you don't have to have the CAS for the AP exam. So we're going to start with a AP kind of question, right? Or AP kind of function.
Yes.
Okay. And so Vicki picked an equation that is not a typical one that you might see on the AP or in an Algebra 2 classroom.
But it is typical of something that you might see on the AP exam.
Exactly. It has a linear combined with, or added to an exponential. Now, I always do this in my classroom. I make mistakes like this all the time. We want to do x squared plus 2x or minus 2x. And I'm doing this mistake on purpose. What mistake have I just made, Vicki?
You left your cursor in the exponent and forgot to, I always call it bring it down so that it's in line with and makes a polynomial that we actually want. And I do it too.
Yeah, I do it all the time. And that's what the pretty print is so valuable. If we, and I think I might have actually gotten out of my, so I actually use, it's good that it's x squared in this case. But if that had been like x cubed, it was a very common mistake the kids will make. So here's our function, okay? So that's function 1, or that's operation 1. So what do you want me to do with it now, Vicki?
Okay, so what we kind of talked about is that maybe we ought to look at some intersection points. And so let's also graph the horizontal line y equals 3. So what Corey's going to do is press tab so that he brings up his function line again and types 3 and enter.
Okay.
So we see obviously that the graphs intersect at 2 different points. And so one of the skills that students need to be able to do is find that intersection point, because that would be solving an equation. It would be setting f1 of x equal to f2 of x and solving for x. So Corey, I'll let you pick your method there, because there are 2 possibilities of what we can do. I tend to encourage my calculus students, if there are 2 points of intersection and you need to know the coordinates of both, that perhaps you want to do your menu and go down to your geometry menu. Although the analyze graph does have an intersection point, it will only find one at a time. And so in this case, we'll go to points and lines and intersection point. And the prompt is to basically select the two functions. And so we're going to select our F1, our F2, and we have our 2 points of intersection. Now, they kind of overlap here in this particular window. So what Corey is doing is dragging those 2 points of intersection. Now, those of you, go ahead.
No, as I say, one of the things my students often forget to do is they notice this tool is still on, and I do it too, and I'm sure you do as well, Vicki. Forget to put away your tools.
Yes.
So you put those away by hitting escape. Otherwise, you're looking to construct another intersection point.
Correct. Yes, or you're trying to do something else and you can't.
Right. I'd like to.
And they get very
like
flustered sometimes.
Right. So they always have to pay attention to what's up here. If you're not Nspire, now that's not the way it's done on the 84.
Right. We're going to do this very same problem on the 84 in just a few minutes. But Corey, before we leave the Nspire, those of you that are very familiar with the calculator responses that students should have on the AP exam know that we need 3 decimal places. And if you notice, one of those x-coordinates of the points of intersection is not. So what Corey is going to do is hover over that x-coordinate. It says text, and all he has to do now is press the plus sign, and it will add digits.
Wait a second.
Yeah, I think you, well,
okay.
Yeah.
Yeah, I missed it.
That's okay.
Yeah, it's not working off my keyboard.
Yes, it's a little harder on the keyboard. It's actually easier on the handheld.
On the handheld, yeah, I have to actually do it with the attributes here, I think.
Okay, that's fine.
But you can get, you can get more decimal places by hitting. So the plus, I wasn't able to hit the plus key on my computer to get it to work.
That's fine.
That's odd. Yeah.
Okay.
Oh, now it's working. Now
it's working. Yeah, I think you had just already selected it. It's fine.
Yeah.
And before we leave the Nspire, and we're going to do this quickly, so you may need to review the video in order to see this. And I know we've talked about it in some previous webinars that we've had. Sometimes the students actually need to store those values. So Corey, if you could hover over it and then press our variables button, which is VAR on the keypad, and store variable, and we can just, I always prefer to rename them. I probably would do like A and B, and this one would probably be the one that's B, so let's just select, it doesn't matter, A or B. It's fine.
Okay, I called that A.
That's fine. So notice that the value, on the screen it looks bold, and that's just sort of a way that you know that it's actually been stored. So now that if you go to the calculator screen or the calculator application and we add a page, so Corey's going to do control document to add a page. If he types either A or B here, we would actually see those values. And then we could continue to use them throughout other aspects or parts of the problem. So that's something that students really need to know how to do. So review this little video if you're using the TI-Nspire and make sure your students can do this. So, Corey, I think we can probably go to the 84 now.
Okay. Well, for those of you who are 84 users, we went past this pretty quickly when we went there were 2 ways, and Vicki mentioned the analyze graph. So if you are an 84 user that's maybe just getting used to the Nspire, this is where all your familiar functionalities for minimum, maximum, and integrals and such, intersections, live, like the second calc menu. So that's if we go to here, to the 84, and we use our function x minus 4, and it was plus.
Yes.
So let me type, oops, not alpha. Trying to spell, so x squared. The only thing, switching from the 84 to the Nspire to the 84, I can't type my keyboard. So those of you who are switching back and forth like me know you get tripped up in certain situations, or you have to adjust which model you're on. So here's that same function, and again, if we're trying to find the intersection of that function and 3, I can now examine the graph of those two. And we will be using the 84 CE. We are going to be using some of the functionality that is exclusive to the latest update to the CE model. So if you have the 84 Silver or 84 Plus, whatever, with the the batteries and black and white screens. Some of the things we're going to do tonight won't work for you. You can still do them differently, but there are some nice functionalities. Anyway, so to find the intersection here, I have to use second and then calc, and then find number 5, intersect. And I know I can press 5. I just always scroll when I'm presenting so that everybody follows me without getting lost. And then I have to tell it which 2 functions I want. So I hit enter on the first curve, and it automatically toggles to the second. That's in case I had more than 2 functions. And then I have to do the intersection points one by one. So I'm going to go over to the one on the right, which I called A, and Vicki wanted to call B, and I get, not surprisingly, the same number. Now, at this point, the value that is there, the 2.5, 2.576, so on, is stored in the calculator as X. And if I go to the home screen and hit X store A, I'm surprised there are a lot of people who don't quite remember this or weren't aware of this. I've now stored that value the same way. So now I can use this in a calculation. For example, like if I were trying to find the area between those 2 curves, I could use this value. Students have to store all of the values in their calculator and then report their final answer to 3 decimal places. So not only did they want to see the decimals before, they actually needed to keep these. So if I was trying to find the area between these 2 curves, I would have to keep that value and the other intersection, which I'm not going to find here in the interest of time, and then I could use A and B in terms of my integrals. And there's actually more than are stored on the screen in the memory of the calculator. So that's kind of the first 2, I guess, that we were talking about. Although I do want to mention I'm a big advocate for the 84 oops, sorry, not that. I want to hit the math. There is something called the solver that has some updates, and that was under math and then up. So if I did that too quickly for you, from the home screen, simply press math and up arrow. And you notice right here on my CE, there's the piecewise, but there's the solver, and I could put in my 2 equations and solve them here. X minus 4 plus e to the x squared or whatever it was. Oh, I keep doing the alpha. I guess we are going to have plenty to do.
We're not in school mode yet.
No, I'm not. You were right. You called me on that one. If I hit 3 here and simply hit the soft key for OK, it returns. Now, it only returns one of the answers, and I'd have to go and get the other. And that's the disadvantage of the solver and looking at it graphically. But it does. That solver has become one of my new favorite functions. And it's a little cleaner now than it used to be on older versions. So do we want to maybe go back into the Nspire and do a example of the other 2 at this point, other 2 calculator functionalities? Or Sure. Okay.
Okay. Well, actually, we could let's evaluate a derivative at a point. And so okay. I like to remind my students that there's a nice menu for that. And so, yes. Corey, if you'll press menu, and then we'll go to the calculus menu. Okay. And there's actually the number 2, derivative at a point. So I really encourage my students to make use of that tool. And so obviously our variable is x. We'll just use the function that we've already graphed. We would want a derivative at some point. Let's just find the derivative at x equals 2, just for convenience. And so notice that the 3rd line says that we want to find the first derivative. We have options of other derivatives, but let's just find our first derivative so we were finding the slope of a tangent line. And so, okay. And look at the nice format that we have here. The only thing that's left for us to enter is the actual function. So let's put in f1 of x, which is that linear plus exponential that we had there.
And I love that you're right that it turned bold.
Yes. And also, you have to use function notation, but the beauty of the Nspire in this case is that you don't have to find a special key for the function name. You just simply type an F and then a 1 and then use your parenthesis for your function notation.
And then it would find it for me.
Oh, look, it's well, that was an accident.
Yeah, that really, I guess we should have picked a different number, but I love it when things work out nicely.
Yes. All right.
We could find this area, this bounded area now, couldn't we?
I think that would be a good thing to do since we've stored those values.
Yeah. So how would I do that then, Vicki?
So let's find a definite integral. So we will go back. We can either do the template or we can go through the menus. But let's try templates for something a little bit different. And so if you see on the third line, the second one over is a nice definite integral template. All right, there. So Corey's going to select that. And then since we've stored those intersection x coordinates as A and B, we can simply do B to A.
Sorry, I know what you were thinking.
That's okay. And
so
let's see, we need upper function minus lower function. So in this case, it would be F2 of X minus F1 of X.
Wait, I did everything backwards tonight.
That's okay. Well, okay, but it's actually a good thing. Students have to be observant of what they're putting in their calculator. So the calculator can only do what the user tells it to do. And so it's important. One of the reasons that I selected that particular kind of unusual function is that I always tell my students, take the 2 or 3 seconds to just look carefully. Did you type it in correctly? Because if you're going to do a free response question and use that function multiple times, you need to make sure that it's typed correctly. You just need to take that time to do this. And I think students just hurry and are careless about those kinds of things.
And especially on a question where they're very complicated. This year, both of the calculator questions had very complicated function, unusual. They just had lots of parts that they could easily type in something wrong, and one little mistake will throw off your whole problem. They could have also defined the function here within the. We're going to do that a little bit later on when we get to the escalator problem, so I'll hold that off. So
okay.
Okay, and then
so someone has asked, Corey, hold on one second. Go back to the Nspire just a second. So someone has asked, can we shade the integral here? And yes, we can. Which is really nice if you want to put something like a shaded region on like copy it and to put it on a quiz or a test. I do discourage my students from actually finding bounded areas on the graphing application. I prefer the students do it on their calculator application. But here's bounded area. So Corey will show that real quickly.
Oh, you want me to actually do it? Okay.
Sure, why not? Let's show them that it'll actually shade it here. So our lower bound, all we have to do is click the intersection point, click the other intersection point. Oh, look, how nice. And there's a 1 decimal place approximation of our area. That was a tongue twister there for a second.
Yeah, and I'm having some trouble with the keyboard getting it to extend the decimal points, but that's the answer there, and I can change that. It is easier when you just hover on it to get it to change on your handheld than it is here for some reason.
Okay.
But anyway, okay. Well,
all right, so back to the 84. Let's give some 84 people a little taste of these things.
And these same functionalities are in the, and they've been on the 84 since they have incorporated the pretty print. And I always forget, oh gosh, where are they and which is which in these alpha y equals or alpha F1. This is the fraction menu. And if you forget, like me, I just hit one of them, then they tell me. So I want the one, I don't want matrices and I don't want the y variable, so it's got to be function. So it's alpha F2. And this looks like the old fn int and the n-derive commands, but when you select them, they have the same templates. So if you know these templates on the 84, you can get the same templates on the Nspire, and I think they're really coming together very nicely, that they're not as different as they once were. So I can do X here, and we want to do the function. Now, instead of putting F1, I know that I have that function stored in Y1, so I can do alpha trace and put Y1 in its place, and I can find the derivative of Y1 at X equals, and what was it? We did 2, so we got that
I think it was 2.
Answer.
Yep.
Yeah. Oh, it's interesting. It's actually slightly, it's 3.5 zeros and a bunch of 3. So
3.
I'm thinking that's round off error probably.
Yes.
And yeah, I'm sure that's a round off error. And I remember, you know, again, they're in agreement to 3 decimal places, so that's fine. And then
So
alpha.
Corey, before you
Yep.
leave, you've accessed the Y1 in a way that I rarely use, but I knew it was there. I typically go through the variables key, so you might want to show them if that way to find the Y1 also.
Yeah, I remember vars, Y vars, function, and I remember having to, like, I'd lose half my kids by now. But that's how you get it. It's vars, Y vars, it's vars, Y vars, function, and then Y1 or Y2, whichever you want. But a couple years ago, they went alpha trace gives you the Y functions much cleaner. And that's great, not only for calculus in this case, but it's also really great when you're trying to do a regression. You can throw those regression equations in any of these Y equal spots. So, I at first didn't realize this was here either, but once I started doing a lot more with statistics and calculus, I was like, oh, that was beauty on their part. I was really pleased that these Y equals are easily accessible without having to go 4 menus deep. So that's another little trick that you might all want to take away from this. So anyway, so thanks you for that. The other functionality is fn int, and my only problem was I stored A before, and I stored the upper limit, but I didn't store the lower limit. I never actually did find that limit, I think, when we were graphing it before. I think so. Right intersection. I would have found it and done it the same way, where once I had it, immediately, when you do, and this, if you don't do this with an 84, you need to start trying to get your kids especially for the AP exam, if you have them find an intersection, you want them to immediately store it. So if I were going to do second calc and intersection, I'm going to go the first curve, second curve, and then get closer to this left intersection. Now that I've got it, as soon as I've got it, I want to store it. So I'm going to go home, clear this out, and say X store B. And that, because as soon as if I do that, then I've captured it as A and B. If I don't store it, if I trace and move, wherever your cursor is when you're tracing, so if I go back here and start tracing now and start moving around and fiddling and doing whatever it is I do, as soon as I move, I now have changed X, and X, I've lost that intersection point. But after you complete the intersection, store it, then I've got it captured to A and B, and I can use it in an integral. Okay, and I don't think I need to do the integral. It's exactly the same as what we showed on the 84. So, okay.
Okay.
Yeah. All right. Now, I don't know. I mean, Vicki, maybe. I mean, you have taught more years than me, and I know you've taught calculus longer than me. And I don't feel like I'm a bad calculus teacher, but my calculus kids never know when to use their calculator. They will try to do things like they've been told calculators are bad and show everything. And so later on in the course, when I ask them to find a derivative of a complicated function at 3, they're going to try to do it by hand or finding a definite integral. And they try to do things on their calculator or solve an equation that a complicated equation like the one we did. They might try to find the zeros of this function. Do your kids do that, or is it just me?
No, my kids do that, and once you participate in the AP reading, you're going to find out that a number of kids try to do whatever you want to call it, algebraically, or find a derivative, or actually take an antiderivative. They will just really try to do some of these functions that we give them on the calculator active problems, and many times, especially with antiderivatives, it has no known closed form of an antiderivative, but they'll insist that they can do it.
Yes, thank you. I'm glad. I mean, and honestly, Vicki didn't know I was going to ask her that question, but I know I knew her answer before I even asked her. My kids will try to find things so they don't know when to use their calculator. And I'm sure some of you out there experience the same thing. And if you don't, please tell me how you solved it, because the only way I could do it was we had a quiz later on in the course. I'm not talking about early on. And I've been saying all year, these are the 4 things you can do. These are the 4 things you can do. And so I give them a quiz. It's called Calculator or No Calculator. And the problem is there are 8 questions, and they have to answer yes or no. Can I do this with my calculator? And if I can, then do it. So how about number 1? Can we do number 1? what kind of integral is that? That is an indefinite integral. Now on my Nspire, I can do that. Okay, I can do an indefinite integral, and my kids have. Remember, Vicki and I both teach with CAS, so they have used this and discovered this, and they will say, "Oh yeah, hey, I can do that." And if they put that down without any justification, now this is not a terrible integral, and one we probably have done before, but they can't do that without justification on the AP exam. So as we go through this, I go through this second one is one we just saw. This is the average value of function, which, oh my gosh, we can never do that enough. How about number 3? Can we do number 3 with the calculator or without the calculator?
Yes, we can do that on the calculator. As a matter of fact,
Okay.
someone just sort of asked that question as to what they need to show on the exam.
Yeah.
Basically, they need to state the equation they're solving. So in this case, if they're finding zeros, they would say f of x equals 0. They don't even have to write x squared minus 3x minus 5. They could just write f of x equals 0, and then right underneath it, x equals whatever they find on their calculator.
And so if they were to do this on the 84, now the only problem with this one is if I try to do this with the solver, if I try to go down to my friend the solver, and I forget it was, I think, x squared plus 3x minus 5 or something like that. I'm not exactly sure. And if I put 0 down here, the solver won't always, it'll only give you the one answer, okay? I know this is a quadratic, and I would anticipate 2 solutions. So a graphical approach is always a little better when you're using the 84. But the solver has some great advantages. So with the CAS device, the kids can do this with the algebra command solve, and I'm sure I'm getting the wrong equation in here.
I think it was, oh, I can't remember. That's it, I think.
I have it right in front of me. This is why I printed it.
I think it's minus.
Yeah, 3x minus 5. With the CAS device, when they're solving an equation, it's comma x, and it will solve it with use the quadratic equation in this case. If they want a decimal solution, they must press Control before they hit Enter. My only problem with the solve command on the CAS is sometimes with trigonometric equations, it tries to find all solutions because of the periodic nature of those functions, and it brings in the multiple solutions, which confuse kids. So
yes.
I still think the graphing is the best way to solve equations.
I totally agree.
Okay, so there are other options, but the good old graphing approach usually works best for me. So let's see, back to the questions here, the other ones. And this is, Mike will send this out. This is a nice little nasty derivative that they can do and spend a ton of time on symbolically. There'll be something we'll talk about, I think Vicki mentioned a little bit later on. This is an equation that you can simplify. You can find the derivative of using chain rule and another chain rule. And what they would expect to see kids do is, I assume, do multiple chain rule. But if they tried to do too much and the calculator might do some crazy algebra simplification if I were to just put this into the CAS. And that actually happened a little bit in some, I think Vicki has more history on that, so she might tell you more about that. But this is not something they should do in the calculator, but number 6 is. And finally, this is the one that seems to confuse my kids. They don't want to, or where was it? It was the minimum one. They always want to do this. They have been taught this, they've shown this, and the kids ask me, why can't I just use the calculator to find a minimum? And I might let Vicki try to respond to that. Why can't they just use the calculator to find the minimum, Miss Carter?
Because they need to demonstrate that they understand how calculus helps them find a minimum, and that means they need to have their derivative and find their critical points and then justify their minimum. And so if those steps aren't there, then they wouldn't get much credit at all. Now, does that mean they can't also check their work and find the minimum on their calculator? That's a very legitimate thing to do, and I think that's a good use of the calculator, but they must show their calculus.
And I love that last part because, I mean, no answer you're going to give them is really good. If you have that kid who's going to say, why can't I just find the answer on my calculator? That's a good answer. Is yeah, you can, but you have to satisfy the calculus requirement. But then you can make sure you're right. And it's kind of nice knowing if you're right before you walk out the door, isn't it? So
yes, and actually, to me, and I'm sure the same is true for you, Corey, that's an advantage of using the CAS in the calculus classroom. There are a number of things that we do actually just in class where we're not thinking about really the AP exam. We're thinking about learning calculus, and the CAS gives us a great way to check our work. And the 84 in many cases will do the same thing.
Yep. Okay, Ms. Carter, you were absolutely right. We need to probably pick up the pace a little bit and talk about limits, huh? So let's
get some piecewise graphs going.
You want to go straight to that piecewise problem? Let's do that. Many of you could, we could put in a function here and graphically do it, but let's show the case the piecewise function that's new to the calculator. So we're going to do a piecewise function and try to determine whether it's continuous. So I'm going to make a piecewise function on the 84, and if you haven't seen this yet, it's pretty nice. I cleared out my function, went to y equals, and went back to that piecewise. I showed you it was under the math functionality, so it's the next to last one. I've heard that they'll always keep the solver as the last one in the math, because a lot of people really like that. But while you're in the y equals, if you choose this piecewise function, piecewise command, you can choose the number of pieces, and I don't want 3, I only want 2, and if I hit OK, now I get a nice little piecewise template that I can put in here. And I'm not going to make a very complicated, we're going to try to figure out if these two pieces, this is a very common type of problem I see in my book. So I have like x squared, x is less than 1, so I go to the second test, and it would be here. And then they might have in the other one k plus, or there's k minus x. So I'm going to do alpha k minus x. And then I'm going to use that for x greater than or equal to 1. And we want to figure out the value of k that makes this continuous. And continuity, and Vicki will speak to that a little bit later, but continuity is a huge, huge deal, especially this year on the L'Hopital's rule problem. But what value of k would make that continuous? Well, I don't know about you, but my kids would type it in just like it was and then press, I saw your flash up. Those of you who don't have this piecewise command, if you're trying to follow along on your 84 CE, you have to update to the latest operating system. I'm using the stuff that's new to the most recent update. So here's what the graph would look like, but I have no idea what it's doing. I just typed it in using K. And this is interesting because I posed this problem to Vicki, and Vicki was like, well, wonder what it was doing. So what is it doing here? What did you figure out that it was doing, Vicki?
So after looking at it, I realized that the default was that k would be 0, and because that made sense for the graph that I was actually seeing. And so then Corey and I went into a discussion about how valuable piecewise functions are. And as many of you know when you teach calculus, is that we can work with our limits. And in order for this function to be continuous, we need to have the limit from the left of 1 and the limit from the right of 1 needs to be equal. So Corey said it's a big deal about continuity. It's a big deal to understand the definition of continuity. It is a big deal to write limits correctly using syntax that is appropriate and used in textbooks. And we've got to really work with our students on that because we saw some very, very sloppy limit notation on the AP exam this year. So this nice piecewise graph actually lends itself to a nice discussion of limits and continuity and the fact that we've got a jump discontinuity at the moment. So Corey, what should we do in order to find a k value that would make this continuous?
Well, we need to change the value of k because whatever the value of k, first of all, we had to figure out what the value of k is. And if my students were just being, literal, they would type this in and they wouldn't know what they were actually looking at. And they're not as sophisticated as Vicki, so they might sit down and say alpha k. I'd say, well, let's figure out what the calculator is thinking. And k is 0. Now, okay, well, that makes sense. Get it? Okay, it makes sense. Sorry, bad joke. So let's change the value of k. So what's the next number they might try? Well, they're not going to go straight to the answer. They're going to say, okay, well, k is 1. Let's store 1 in for k and see if that helps. So now I've stored it and see what that did. Well, hey, it's closer. And then they would fiddle with the value of k. Now, obviously, this is a pretty simple one to play with. They would, if they change the value of k to 2, that would make the limit from the left and the limit from the right be equal, and then the pieces would meet. So if we store 2 into k, then it should intersect. And I can then examine it by tracing and see that now I'm on the other piece. So I could do 0.9, and it's close to 1, and 1.1, and it's close to 1. And so if
and Corey, maybe we want to look at the table right quick too.
Oh, should do that, yes. And so I can look at it there, and then I can look at the table and see that they are, now I don't like that it's populated all here, so I would actually change my table setting to independent to ask, so we can approach it from both sides. So I would, go back to my table. Now I don't have any x values, so I could do what I was trying to do graphically. I could put, let's say, 0.7 and 1.3 and squeeze down to 1. So I could put 0.897 and 1. I made an icky number here, something like that. And see that they squeeze down. So as I get to closer to, I've started to not try to just do 999 because they want to go here too quick.
First, they don't want to look at it as a sequential.
They don't want to look at, so I try to do odd ones rather than not jumping straight there. So it's nice to not just go into.
I really like your selection of odd values there.
Yeah, my odd values, but those two numbers are squeezing down to each other. What is happening to the y values? And that's not the formal language, but that's the limit from the left approaching 1 and the limit from the right approaching 1. And that's in notation. And that's one thing I have picked up from working with Vicki over these last few years. If you haven't been on you read some of the revisions, the notation is becoming it's much more important. So, do you want to look at the same problem on the 80 and the Nspire, or where do you want to go?
Well, it might benefit them to at least see the template and then pop up a table real quick if they don't know how that works.
Sure, we should do that. Yes. So let's make a new page. You want to do it on the graph or on a calculator?
Well, let's just go ahead and do it on the graph page.
Okay. So the piecewise template will be in F3. So I'm going to press that same, I call this the math button. I'm not sure if that's the official name, but it's got
I just call it the template button, but it's fine. Yeah, math template.
The math template buttons. Here are the piecewise functions. The first one here is for 2 conditions.
Yes.
Or 2 pieces, and then the second one would do 3 or more. Oh, I should mention the 84 has a limit of 5 pieces. You cannot do more than 5 pieces. But here's that same function template, and from here it pretty much operates the same way. And it's control equals here above it in blue is where the inequality symbols are. So I assume it would still do the same thing because we haven't played when put anything in to this.
Okay, so what's going to happen, someone has already asked this, if you put the K in on the Nspire, you get a slider. And they weren't sure what to do, so they were working on the Nspire when you were working on the 84.
Oh, that's right. That's the new, whenever you use the, when you use a constant now, you get any other variable, you get a slider. Ooh,
right.
I wasn't thinking about it. Yes, they actually will allow you to create a slider, which in this case I kind of love because you actually can slide that linear piece.
Yeah.
This is a new functionality. I didn't anticipate this because I hadn't worked this problem on the Nspire. Whenever you use a constant, what we would consider a constant, it attempts to create a slider for you right away. and then it would do that. And here I've got a slider for K that would allow me to change it on the screen.
So kind of two ways of thinking about it. With the 84, I guess in one sense the students are trying to kind of play the guess and check game. They guessed one, guessed two, trying to get close so that they could see that the function becomes continuous. And in this case, it's still sort of a guess and check, but they've got the slider to help them.
Yeah, I'm not sure which one I actually like better now. I mean, I didn't anticipate this, but I wasn't. I was thinking about doing this problem on the Nspire. I was simply trying to think of it. But that is a new. So if you were to do x squared plus a would become a slider on the Nspire now.
Yes. So let me warn everyone who's using the TI-Nspire, because this is going to happen to you. When you get, and I know this isn't the topic of our webinar, but when you get to motion problems in which the variable, the independent variable is t, if they want to do something on their calculator like a graph of maybe a position or a velocity function, they've got to use x. You will not believe how many times the hands will go up and go, I just got a slider on my screen. Basically, that's telling you they've actually tried to graph with an independent variable of t instead of x. So that's just a hint.
Okay. And that's going to be interesting when you're doing a function with a limit as x, too, yeah. So,
yeah.
Okay.
All right, so we've looked a little bit at, let's do a table real quick. So if you'll do control, so on the Nspire, a very quick way to get a table is to press Control T, and I guess you're going to have to go over a little bit there to.
Yeah, I have to change my. You want me to? So I thought you wanted me to change the settings. So you want me to go? Want me to scroll through the table, or what do you want?
Well, I mean, we can. So basically, you can see that's all we really need to look at. So some people don't. A lot of people don't know how to get a table up quickly when they're looking at a graph. So we'd have to play with it a little bit. But the Control T will bring your table up. And then when you are done with your table, you can just press Control T again, and your table will disappear. So that's just sort of a handy thing to know when you want to look at a table with the TI-Nspire.
Okay. Well, we want to look at the famous escalator problem. We got about 10 minutes left.
Let's do a little bit with it if we can.
Okay. You want me to make a new document?
I think that probably would be a good idea.
Yeah. So I'm going to start with a new document. And I'm not going to save our work. We have some of the work we've done, and Mike will send that to you afterwards. So let's, I don't have the question in front of me. Many of you have seen the escalator problem, I'm sure.
I'll read it real quickly. I've got it right here.
Do you want me to define the function?
Yes. Do you
okay, I'll define while you read.
Okay. So people enter a line for an escalator at a rate modeled by the function r, given by, and in this case it was a piecewise function, although one piece was equal to 0 for t greater than 300. And Corey's typing in the other part, where r of t is measured in people per second and t is measured in seconds. As people get on the escalator, they exit the line at a constant rate of 0.7 persons per second. There are 20 people in the line at t equals 0.
Okay.
So as Corey finishes typing there.
I probably could have had.
So as Corey said, this was a fairly complicated, I mean, it didn't take a great deal of time, but it was enough that the students, again, needed to stop and reflect that they had typed it incorrectly. So this is, the interval is 0, less than or equal to t, less than or equal to 300.
And then the other piece was 0 for
t greater than 300. Oops.
I got it. I think that's it. Okay, good.
So we were trying to think about a way to actually have an extension of this problem and think about some of the things that we've already done tonight. So what if we wanted to know when the rate at which the people enter the line for the escalator is, Corey, I can't remember what we said, 2 people per second, I think. Yes, so what could we actually do? If you think about what we've done earlier with solving equations, what could we possibly do here?
Well, if we want to solve where this is our rate function, so
right.
I could solve where this is equal to 2. So I could use the solve command, or
Correct.
I could graph it and intersect it with the horizontal line 2. So we could go either way. Which way would you like to go?
Let's just solve on the home screen. I mean, on the calculator app here. This is not a trig function, so I wouldn't expect to have a lot of problems with it. And so notice that Corey's being very careful about the variables that he's using. This is something also that students are very careless about, and I think it really teaches them better notation when they use both of these calculators.
On the 84, you would have to switch the variable x.
True.
But on the Nspire, I can use the given variables, and it will work just fine. And so, what's going on? I think my screen just froze.
Uh-oh. Yes, it does look like it froze.
Yeah, my screen has just frozen. So.
Okay, well, let's go to the TI-84.
Okay, so let's.
So
that's interesting.
even people who are in the know have trouble sometimes with things like this.
Yeah. Well, we're almost at it. I mean, and that would have solved it. And so it. I don't know. My screen, my calculator or my CE just froze. So
Corey,
I've
had that problem occasionally when I've worked with both calculators at the same time on a computer. So
probably, and I'm doing a webinar. I'm pushing my old 3-year-old MacBook pretty hard. The only reason now, here's something: if you're an 84 user, I just save myself a lot of time. If you use SmartView, you can save your emulator state under Actions. If you have, and this is what you'll receive from the webinar, you can save. So if you're a fire drill or you're in the middle of a problem, the bell's ringing, and you're going to lose time, you can save where you were. So I've actually already typed it in and saved it, so you can load it later on, so you can bring it back exactly where you were the next day. And I just saved myself a bunch of time because we only have about 5 minutes left. So here I can now graph that function. I'm going to turn off the accumulation function because we don't want to get into that right now. And I need a better window. I know that this was set for the accumulation function. I think it was going maybe up to 10. I need my X value to be 300. This is another reason that I like the Windows on the 84, but I mean on the Nspire. So here's the rate function, and we want to find out when this equals to.
I think I said 2.
2. Yeah. So I could then graph 2 as well, and find where that intersects. So I could find the intersection points using the intersection command. Okay, so I'm going to choose the rate curve, the constant, and I'm going to go over here and find this first instance where it equals to 2. And so that happened at a little bit over 60 seconds. 60
Correct.
Seconds.
So,
okay.
So that's a nice kind of recap of what we did earlier.
The other thing that I had in here that was the accumulation function. This is actually part D, and the only other thing that I want to kind of talk about with this, and it graphs very nicely on the Nspire and on the 84 on the computer, but this is actually part D of the problem. And if I were to graph this function now, I do need to change my window, my WiMAX, because the number of people online gets pretty high, even if the kids laugh at it. If I were to graph this right now, it's graphing very quickly, but on the handheld, it takes much longer. And I'm using the processing power of my calculator. So I've seen some people who are working this problem and doing the integral approach. And notice this is part D. They're asked to find a minimum. I can find it. It's right there. And that verifies, like Vicki said, this minimum occurs at, 33 seconds or around 33 seconds? Yeah. And there were, it was interesting, this year they had to say the number of people in the whole number. So even though this minimum occurs, oops, wrong one. The minimum, I got to quit out of that. I want second calc, I want minimum. So I would go to the left and to the right. thinking about it. Oh, it's even going to take it a while. This takes a long time, okay? And I'm broken now. I'm stuck on something. I can escape out of it by hitting on. So if you're trying to graph that on the 84 on the handheld, it takes about 5 to 7 minutes, and you don't have that time during the test. So I'm going to break out of it. That's what I wanted to show you, is you can break out of these by hitting quit, and that'll stop an operation that is not going well for you on the 84. And so the other way to do that is to change your XRes to a number other than 1, like 3 or 4, and it graphs every third pixel. So that would speed up your 84 if you were trying to do an accumulation function. So if they don't realize if they realize they're stuck on something, if I go and change that XRes to 1, watch how much slower this graph generates. It's generating all of those. And on the handheld, it's even slower. So I could break out by hitting on, and that would stop the process. Okay? So I think that's probably about as far as we can go. The only other thing, I don't think we have time because it's the drop-dead time.
Yes.
There is, well, actually, let me see if I can do it real quick. I wanted to bring out, I just discovered this as well. Back to the original rate function, if I wanted to find the rate of the rate, for example, or to just do a tangent line to a function, on the 84 CE, you can, while you're tracing on a function, so if I wanted to find the tangent, and I'll let Vicki, we'll do Vicki's, I guess I don't need to do, maybe I'll do 22. If I wanted to find the tangent line at 22, I could go to second draw and number 5 tangent, and it will draw the tangent line at that point. Or it should have. Oh, now, there it goes. There's the tangent line at approximately 22. There's your tangent line at that point. It's using the pixel, which is closest to the one I picked. So there's that's pretty much as far as we're going to go. We have to turn control back over to Mike. So I'm going to stop sharing my screen and return control to Mike. Thank you very much.
Thanks so much, Corey and Vicki. We had a couple people asking about how to update their TI-84 or TI-Nspire, and there's some really great resources available on our website, education.ti.com. So if you visit our website and go into the Resources tab, at the bottom of the middle section is Tutorials. So first, let's look at the graphing tutorials for the TI-83 Plus and TI-84 Plus. So let's say you have the TI-84 Plus, maybe not even the Plus C, just a regular Plus, like I had growing up. I checked that it's under section L. So under section L, there we go, using TI Connect. Operating the operating system on the calculator is a short free video, 3 minutes and 3 seconds. So that'll get you some information on how to update your TI-84 if you're not using the most recent updating system. If you have the TI-84 Plus C or the CE, you can also use our website under Resources and Tutorials to update those.
So Mike, really quickly, could you also show them where the TI-Nfocus is about the calculus? Because several people are asking about how to know more about these questions and using their calculator resources. This will be posted later this fall.
Great idea. Thanks so much. So before I do TI-Nfocus, let me just show TI-Nspire real quick. Let's say you have the TI-Nspire and you want to update that. I didn't look necessarily where it's going to be, but I would guess almost the same section, but there's going to be a video on how to update your TI-Nspire. And Vicki had mentioned the TI-Nfocus. So also under Resources, same tab, there's this really new, nice plethora of information that's been compiled specifically for calculus called TI-Nfocus. And if you click on TI-Nfocus, I'll just show this briefly. You can select a specific topic that you're looking to teach. So let's say you're looking to teach maybe the fundamental theorem of calc, and you can pick a year. There's only been 1 year of data collected. This is going to continue to roll in the future, so the 2018 problem will be there, et cetera, et cetera. What I've loved about this using with my students is there's some really exciting resources. So the resources are for not only Nspire, also 84, but there's also scoring and common errors, technology solutions and extensions. You can download a PDF of some kind of instructional material slides that I've used with my students. These are really worth, I think, checking out. So, Vicki, thanks so much for reminding me about that. Please take a few moments whenever you have a chance and look under the Resources tab and TI in Focus on our website, education.ti.com. And we are out of time, so let me jump to the certificate of attendance. So to receive your certificate of attendance, go ahead and click the link in the chat window. Right now, there we go. Also listed is a link to the documents that were used by Corey and Vicki. If you happen to miss these for any reason or they're not working, just hang tight. You'll automatically get a follow-up email in a couple days, and in that follow-up email will be a link to the certificate, a link to the documents, and also a link to the recording. And if you're watching this on demand, just go ahead and copy that link into your favorite browser to receive your certificate. Thanks so much, Corey and Vicki, for everything you shared tonight. I really appreciate it. I'm looking forward to getting back in the classroom and teaching some calculus.
Me too.
Thanks, guys. Have a great night, and we hope to see you back online real soon.
Good night, everyone.